Good morning, everyone. Very good morning, all of you. All right, very good morning, everyone. Please once confirm if you can hear me properly. And today, guys, we are going to discuss this very important topic, aromaticity. Although this is a very small topic, it's not going to take much of our time, but we might get some really good question of 4 marks from this topic, right? Aromaticity, very, very important. All right, just starting the session. Good morning, guys. Very good morning. Okay, chalo, let's begin the session, guys. Very good morning, everyone, once again. Yes, everything is fine. I'm good. Anubhuti, thank you for asking. Okay, guys. So, aromaticity hai revision series, right? And we have discussed some really important questions of stereochemistry also. Yes, there were few. We have done few questions, but everything cannot be discussed in the free classes, right? But jo important wale question the, those we have already discussed. Right, and tomorrow also we are going to have a session like this whole month, like abhi jitne bhi din bach rahe hain 30 31st, we are also going to have sessions on the same time 9:15. Okay, so yes, guys, the notification is going to be given in this group CSINet 2022. I'll share the link over here just like I always do. All right, और अभी हम start कर देते हैं revision of some really important topics of aromaticity. All right. So yes, guys, you know about the Huckel's rule. Everyone knows about the Huckel's rule, right? That if any molecule, how do we say that any molecule is aromatic? So without wasting much time on this, we are just going to move forward on example after a very quick revision. That is, how do we say that a molecule is aromatic? That is, if it is planar and it is conjugated and if the pi electron cloud follows the Huckel's rule. Follows Huckel's rule, isn't it? What is the Huckel's rule? That the pi electron cloud should be equals to 4n plus 2. Now where n is an integer, n could be 0, 1, 2, 3 and so on and so forth. Right? So this is basically the Huckel's rule. ये सबको पता है. ठीक है? Yes. Now based on this, how many molecules can be considered aromatic? That is what we want to uh, revise. Just once quickly, we are going to revise how many molecules could be considered aromatic based on this criteria. So when the n value is equals to 0, you are having how many electrons? 2 pi electrons. So 2 pi electron में कौन aromatic होता है guys? 2 pi electron में you are having the cyclopropenyl cation. This is aromatic in the 2 pi electron system. Yes, any more? Yes, we have one more guys. ये देखो. What do we call this? इसको हम क्या बोलते हैं गाइस इस मॉलिक्यूल को वेरी पॉपुलर इट इज यस व्हाट डू वी कॉल दिस वी कॉल इट squaric acid yes absolutely we call it squaric acid then and this is also aromatic in nature because within the four membered ring system you are only having 2 pi electrons isn't it yes or squaric acid is very very acidic more acidic than acetic acid जो कि organic acid है why is that so क्योंकि when it loses the two protons what does it become becomes O minus and O minus over here so the bond is going to fall in this way, and you are going to get equivalent resonating structures. All the resonating structures are going to be equivalent like this. Okay, you can just go on and make more and more resonating structures. All of them are going to look like the same thing. Okay, so that is why very highly acidic. ठीक है? Yes, and aromatic compounds में एक बहुत important चीज होती है guys. What is that? Resonance stability या फिर resonance energy, isn't it? So what is the concept of resonance energy? Let's first understand this. Resonance energy is directly proportional to aromaticity. It is directly proportional to stability. Yes, isn't it? देखो, what do we usually say? Usually हम क्या बोलते हैं एक molecule के लिए? That if a molecule has high energy, then it is less stable, isn't it? If a molecule has high energy, it is less stable. But यहाँ मैं क्या बोल रही हूँ? High resonance energy, high stability. How is that possible? Yes, I would write also inversely proportional to potential energy. Inversely proportional to potential energy. Okay, so guys, resonance energy is the energy which is lost, which is the energy difference. ठीक है, तो एक बार आप इसको कंसिडर करो. व्हाट इज द कंसेप्ट ऑफ रेजोनेंस एनर्जी? ये जानना बहुत जरूरी है. व्हाट इज रेजोनेंस एनर्जी? Okay, only discussing the concept, guys. That is, let's say if you are having one साइक्लोहेक्सीन मॉलिक्यूल, तो लेट्स से इस डबल बॉन्ड की जो एक्चुअल एनर्जी है, लेट्स से द एक्चुअल एनर्जी ऑफ अ कार्बन कार्बन डबल बॉन्ड इज x किलो जूल पर मोल. ठीक है, मान लिया x किलो जूल पर मोल है. ठीक है, देन आई एम टेकिंग टू डबल बॉन्ड्स ओवर हियर. आई एम टेकिंग टू डबल बॉन्ड्स, देन इट विल बी 2x मल्टीप्लाइड बाय 2. और मैंने एक और डबल बॉन्ड ले लिया, देन इट शुड बी मल्टीप्लाइड बाय 3, इजंट इट? Yes, so this molecule should be 3x kilojoule per mole. ठीक है, ये होना चाहिए. This has been calculated theoretically. Calculated based on calculation done based on carbon-carbon double bond values. Okay, अब ये जो energy है, what is this energy? 3x kilojoule per mole. What is this energy? इट इज द पोटेंशियल एनर्जी ऑफ दिस मॉलिक्यूल. क्योंकि जब भी हम फाइंड आउट करते हैं बेस्ड ऑन कार्बन कार्बन डबल बॉन्ड, सो कार्बन कार्बन डबल बॉन्ड की इतनी एनर्जी है, दैट मीन्स कि टू ब्रेक द कार्बन कार्बन डबल बॉन्ड वी विल रिक्वायर x किलो जूल पर मोल, एंड टू ब्रेक 3 डबल बॉन्ड्स वी रिक्वायर 3x किलो जूल पर मोल. तो ये क्या हो गई गाइज? दिस इज दी पोटेंशियल एनर्जी, डिसोसिएशन एनर्जी ऑफ दिस मॉलिक्यूल की इस मॉलिक्यूल को इतनी एनर्जी है इसमें, राइट? लेकिन व्हाट इज रेजोनेंस एनर्जी? सो एक्सपेरिमेंटली व्हाट वाज फाउंड आउट? एक्सपेरिमेंटल एनर्जी was found out, let's say y. ठीक है, let's say y. So y तो 3x से कम हो गया, and when we are doing the subtraction we are getting somewhere around 36 value. Okay, so ये जो remainder value है, what is this remainder value? This remainder value is जो minus करके आया है, this difference, this is the resonance energy. Why is there the difference? ये क्यों आया ये difference? Why is not the calculated and the experimental calculations same? ये दोनों same क्यों नहीं है? They are not same because the molecule is not like this. ठीक है, the actual molecule of benzene, it is not like this. It is like this, isn't it? So there is a complete delocalization of the electrons. That is why you cannot say that this is a structure. Alright, और ये जो remaining energy है, this remaining energy is excluded from the molecule, and that is why the molecule becomes stable. So greater the resonance energy, ये देखो ये जो difference वाली energy है guys, this is the resonance energy. Yes, due to aromaticity, absolutely. So resonance energy हो गई है. Yes, so greater the resonance energy, greater is the stability. Why? Because ये तो difference है ना, जितनी ज़्यादा energy निकल जा रही है system से उतना ज़्यादा stable हो जाएगा. So this is the resonance energy. Higher the resonance energy, higher is the stability. Yes, experimental कम होगी theoretical से. Okay, and there's a difference. That difference is called the resonance energy. Okay, Kamal? Yes, तो इसीलिए हम बोलते हैं that resonance energy जितनी ज़्यादा है, stability भी ज़्यादा है, and what next? This is inversely proportional to the potential energy of the molecule. So potential energy is a different concept, resonance energy is a different concept. Okay, now we move onwards guys, and we see one more thing which is very very important for aromaticity. That is a concept which is mixed in aromaticity. बहुत सारे concept mix होते हैं guys. What are the additional concept? Please have a good knowledge of this कि क्या क्या aromaticity के साथ आ सकता है. So aromaticity के साथ क्या आता है guys? First thing आता है acid and base concept. Acid base property, isn't it? Acid base property. Yes, you have already seen some of these example. Let's say इसका question आया, which of the following protons are more acidic, isn't it? Yes, there was a previous year question in this way, no? When I'm only having one bond over here. Yes. So which is going to be the most acidic? A, B or C? Yes. Which is going to be the most acidic? B is going to be more acidic than A and then C, isn't it? तो ये acid base property जो है, that is going to be combined with aromaticity to ask a question. Yes. Second concept which is combined is dipole moment. Dipole moment. For example, which of the following molecule has the maximum dipole moment? Let's say हमारे पास दो molecule है. Alright, we have this molecule and then we have this molecule. Just 1 second. Yes. So in these two, 1 and 2, which has a higher dipole moment? Dipole moment concept is very frequently asked with aromaticity. B is more polar than A. Why? Because A के अंदर क्या है guys? You are having two cyclopentadienyl type of rings. ठीक है? And the electron density cannot shift on any one side. Why? Because then अगर हम इसको ऐसे move कर देते हैं, let's say the electron density is shifted towards one ring, then okay, very well, this one ring is going to become aromatic, but the other ring has a positive charge and this becomes anti-aromatic, isn't it? This becomes anti-aromatic. क्यों? क्योंकि यहाँ पे क्या हो गया, 4n electrons follow कर रहा है. Now there is 4n pi electrons in this system and that is why this is going to be anti-aromatic. Now what happens in this case guys? This is a 7-membered ring and if I just open this double bond onto this 5-membered ring, what happens? ये कौन सा molecule है? Azulene. Isn't it? You remember azulene, right? Azure blue color. Azulene molecule. So the charge separation can happen over here, isn't it? Yes, the charge separation, let's say, I'm saying the charge separation happens along this way. ये हो गया charge separation. ठीक है? And this positive charge, you know guys, it can all the way extend to this corner, this side of the ring also, which makes the dipole moment even higher. क्योंकि maximum the charge separation maximum is going to be the dipole moment. ठीक है? So this molecule has a very high dipole moment. This one does not. Why? Because of a greater charge separation. Because this will now become a tropylium cation. Tropylium cation क्या होता है? Which has a Tropylium cation is one which has 6 pi electrons and one positive charge. So there is a delocalization, 6 pi electron follows the Huckel's rule, absolutely aromatic in nature. और दूसरा क्या हो गया, cyclopentadienyl anion. Yes, so this is also aromatic in nature, both of these. Okay, so that is why we will say dipole moment पे ऐसे question आते हैं. Acid base property, dipole moment. Let's look at one more. That is energy for bond rotation. Energy for bond rotation. Yes, you have seen these kind of questions. That is, let's say, which of the following has the lowest energy for bond rotation? ठीक है, जैसे कि once again I'm taking this molecule, guys. Okay, so what do you think? Minimum energy for the central double bond rotation. I'm talking about the central carbon-carbon double bond. A, B or C? C, is it? Yes, why? Why does A require high bond and high energy for bond rotation? Because we have already drawn the separate, we have done the charge separation and then we have seen कि नहीं भाई कोई भी aromatic नहीं है. If one becomes aromatic, the other will become anti-aromatic. So it's going to take a lot of energy. The molecule is more stable like this, isn't it? What about option number C? Here, if we just move this electron density on this side, yes, negative and positive in this case, isn't it? Yes, तो ये क्या हो गया? This molecule, it has become positive. This is a tropylium cation now. And what about this? This is separately aromatic. Yes, it is going to give you the cyclopentadienyl anion, right? So both of these are aromatic and the double bond will want to stay opened up. So that is why the bond energy या फिर bond rotation barrier is going to be very, very, very low in this case, isn't it? The bond rotation barrier is going to be very, very low in this case, and that is why ये हमारा आंसर हो गया है. ठीक है, absolutely very good. Now one more concept which is asked, तीन concept हमने कर लिए, acid base, dipole moment, energy for bond rotation. One more concept which is very frequently asked that we are going to do. First, I am just going to inform you once दैट गाइज अभी डिटेल बैच जो आप बोल रहे हो बार बार में कि मैम नया सेशन कब से स्टार्ट होगा CSIR नेट के लिए. सो फॉर दो स्टूडेंट्स हु आर वेटिंग फॉर द न्यू सेशंस टू स्टार्ट, गाइज डोंट वेट बिकॉज all the courses of important topics are already made on Unacademy. Okay, what you have to do is you can join anytime and you can just start from the new courses. The new courses are already built up. अब नई live session कब से start होगी? If you want to study live, that you can wait for a few while. ठीक है, just after the exam will start once again. लेकिन अगर आपको सिर्फ पढ़ाई ही करनी है तो फिर आप आ सकते हो, कभी भी क्लास स्टार्ट कर सकते हो और जो ongoing डाउट सेशंस है उसमें डाउट भी पूछ सकते हो. ओके, So yes guys, impulse detailed batch, which is having all the important topics of organic, inorganic and physical, and chemithon practice batch. Now this is a practice batch for the CSIRNet 2022 examination. The courses are already live. You can just visit the courses. Okay. And yes, now we talk about the fourth concept. Concept of resonance energy. अच्छा, इस पे क्वेश्चन आता है that which of the following, very beautiful question guys, which of the following will work as a good diene in the Diels-Alder reaction? In the Diels-Alder reaction, abhi Diels-Alder reaction everyone knows guys, it is 4 plus 2 cycloaddition. Yes, so that is a separate thing. तो pericyclic का question है, but no, look at the options. It is not a pericyclic question, it is a question of aromaticity. Okay, Anubhuti, थोड़ा सा wait करो. After this, I'll show you previous slide, okay? Yes. So this is 1, this is 2, and this is 3. Which of these is going to behave as, yes, behave as a good or a better, yeah, the best diene out of all of these? Which is the best diene? Yes. Which of the following will work as a good diene in the Diels-Alder reaction? Yes, everyone trying out? What is the concept behind this question? That is important. What is it based on? Diene. Who is a diene? A diene should be electron rich and its HOMO should be lower in energy. It is absolutely 1. Absolutely 1. Why? Because the one who is going to be a good diene must be less aromatic. Okay, so this is so important guys. The one which is a good diene must be less aromatic in nature. Why is that so? क्योंकि जो जितना ज्यादा aromatic है guys वो तो उतना stable हो गया. And guys, you're answering, see, Shoaib, you're answering 3. 3 तो बिल्कुल नहीं है. This is the most stable molecule. So, most stable, least reactive. Most stable out of all of these 3 options, okay? So, if I write the resonance energy of all of these molecule, देखो, थायोफीन के लिए होता है 29 किलो कैलोरी पर मोल. For pyrrole, it is 21 kilocalorie per mole. For furan, it is going to be 16 kilocalorie per mole only. This is the resonance energy I'm writing. Okay, and then let's also consider benzene. Benzene का तो standard है, हमें पता है, it is 36 kilocalorie per mole. What about pyridine? Let's also consider pyridine. This is going to be 32 kilocalorie per mole. So guys, just in case a question is asked based on this, कि या तो how it is working as a diene या फिर directly पूछ लिया कि what is the resonance energy, arrange the following in the order of resonance energy, will you be able to answer yes or no? Benzene has maximum resonance energy, then there is pyridine, then there is thiophene, then furan, and last may pyrrole, and that is why pyrrole is the most reactive. Yes, and that is why pyrrole is the most reactive. Now this is first concept on resonance energy. What is the second concept? Let's also discuss. Second question, second type of question, what is the order of aromaticity of the following molecules? Of the following molecules. ठीक है, let's see what the question is asking. That out of all these whatever options I'll be writing, order क्या होगा aromaticity का? Order of aromaticity, very important. First thing, I am writing a simple benzene molecule, and then I will write naphthalene. ये देखो, I will write naphthalene और last में I will write anthracene. तो इन तीनों में से 1, 2, 3. What is the order of aromaticity? Yes, Mohit, pyrrole is more basic, more basic. Or you can check from the pKa values also. Okay, indole और pyrrole का pKa value check करके पता चल जाएगा. Yes, what is the order, guys? Yes, absolutely, guys. See, 1 is more aromatic than 2 and then 3. Why does that happen, guys? Why is it so? Because we see aromaticity is a property of one ring. ठीक है? Please remember this. Aromaticity is the property of one particular ring, of each ring. ठीक है? So if I say that benzene is more aromatic, why do I say that? Because जो भी यहाँ पे aromaticity है, whatever is the energy of benzene, 36 kilocalorie per mole, that is for one single ring, isn't it? That is for one single ring. Or whenever I have two rings connected, तो उससे क्या होता है guys? When I have two rings connected, then even if the energy, see, I'm just writing the resonance energy, आपको देख के लगेगा कि नहीं मैम ये तो increase ही हो रहा है. 36 kilocalorie for benzene. For naphthalene it is 59 kilocalorie per mole, and for anthracene it is 71 kilocalorie per mole. तो आप तो बोलोगे मैम रेजोनेंस एनर्जी तो इंक्रीज हो रहा है, देन व्हाई इज दिस ऑर्डर? ऑर्डर इज 1 greater than 2 greater than 3. Why is that so? Because 36 divided by one single ring is 36. 36 kilocalorie per mole per ring. ठीक है? Yes. अब ये देखो, for naphthalene we have 59 divided by 2. Why? Because there are two rings. So each ring, how much is the resonance energy? That is only 29.5 per ring. This is per ring. Similarly, 73 divided by 3 is equals to 23.67. ठीक है? So this is once again less. तो aromaticity या resonance energy per ring is going to be low. That is why this is the order of aromaticity. 1 greater than 2 greater than 3. Yes, I hope that this is clear to everyone. Yes or no? Yes. ओके नाउ नहीं नहीं योगेश, पीके प्रोटोनेटेड का नहीं बताता है, पीके नॉर्मल उसका भी बताता है. लेट मी जस्ट गिव यू द वैल्यूज वंस. For simple pyrrole, ठीक है, that is losing this proton, this particular proton, it's 23.05. इंडोल के लिए है 20.90. All right, and then if we just go on increasing the benzene ring, let's say इसी पे एक question आ गया. For example, if we go on increasing the benzene ring over here, then how is it going to be? इसका pK हो गया 19.90. What is this molecule? It is carbazole. ये क्या कार्बाजोल है. ठीक है, पाइरोल, इंडोल, कार्बाजोल. yes. What is the basicity order? Now you see who is more basic, guys. pK value is decreasing, so pKa is directly proportional to basicity. And when you go on increasing the conjugation, the lone pair is further used up into different rings. Pyrrole is more aromatic. Pyrrole is yes, pyrrole is more aromatic. It's not the question of aromaticity, it is the question of कि लोन पेयर कितना अवेलेबल है. ये देखो, ये वाला जो प्रोटॉन है गाइस, लेट्स से इफ यू रिमूव दिस प्रोटॉन फ्रॉम हियर, दिस conjugate base मोहित is going to be more stabilized. ठीक है, ये माइनस चार्ज इट इज गोइंग टू बी मोर स्टेबलाइज्ड बिकॉज ऑफ दिस ring, because of this phenyl ring over here. ठीक है, and the phenyl ring is having a minus I effect over this nitrogen lone pair. You increase the number of phenyl rings, there will be greater conjugation, greater stability of the conjugate base, और minus I effect भी ज्यादा है, इसलिए pK value decreases. So basically going from pyrrole to indole to carbazole, this is actually most acidic. मैं ये भी बोल सकती हूँ ना, most acidic, and this is the most basic. Yes. Okay. All right. So yes, based on the pK value, you can get the answer. Now guys, one more important concept. कितने concept हो गए guys हमारे? Yes, अनुभूति, you were saying कि आपको लिखना है. Please write this down. We had considered 4 or 5 concepts till now. एक और concept है guys, very very important, which is also asked under the topic of aromaticity. That is the NMR values. Okay, that is the proton NMR spectrum of aromatic compounds. बहुत ज़्यादा आने लगा है आजकल तो. Yes, mixed with the point group and various things. ठीक है. Yes, so I hope that you have noted down this slide. We will move onwards. Yes. Okay. So what else is more important is the 1H NMR and the C13 NMR values. They are mixed, isn't it? Okay, and most frequently they're asked for the annulenes. Annuline system के लिए बहुत ज़्यादा आता है. Yes. So, yes guys, let's see. For those molecules जो aromatic होते हैं, there is a terminology for those molecules. Okay? They are known as diatropic in nature. And anti-aromatic compounds, they are known as paratropic in nature. ठीक है, what is this concept guys? ये क्या है नया? Diatropic, paratropic. Yes, एंटी एरोमेटिक और एरोमेटिक से काफी नहीं था कि हम एक और चीज उठा के ले आए. राइट, व्हाट इज दिस डायाट्रॉपिक? यस, So let's talk about the aniline system to understand this. It is very, very, very important. Okay. Yes. So let's say I am talking about 18 aniline system. Yes. Let's say I am talking about the 18 aniline system. One double bond, two, three, four, 5, 6, 7, 8 or 9. 9 double bonds होने चाहिए, then only it will be 18 aniline. ठीक है, very well. So 18 aniline system guys. Yes. अब देखो, in the 18 aniline system, what do you see? You have 1, 2, 3, 4, 5 and 6. You have 6 inner hydrogens. Yes or no? 6 inner hydrogen है और बाहर कितने बचेंगे guys? Obviously 18 minus 6 will be 12. So there will be 12 outer hydrogens. Okay? There will be 12 outer hydrogens. Now you tell me one thing. What is the property of the aromatic compound? ये जो diatropic molecule है ना? What is the property of all of these compounds? Diatropic molecule. The property is inner shielded protons, outer deshielded protons, isn't it? मतलब कि जो inner protons रहेंगे of any aromatic molecule or a diatropic molecule, those will be shielded and the outer protons will be deshielded. So the same happens for the 18 aniline system guys. कितने electrons है यहाँ पे? 18 electron है. Is it following the 4n plus 2 rule? Let's check. n की value 4 put करो. n की value 4 put करो. You have 4 into 4, 16 plus 2, 18. Yes. So 4 into 4 plus 2 gives you 18. Yes. 4 into 4 plus 2 gives you 18 electron rule. So 18 aniline system. Yes, definitely 18 aniline system is going to be aromatic in nature. इसलिए outer inner protons जो है they will be shielded and what is the value? Minus 3.0 ppm. And what is the outer deshielded proton value? There will be 12 hydrogen. Inner hydrogen तो 6 है. Outer hydrogens are 12. It is 9 ppm. 9 point something it could be. लेकिन हाँ 9 ppm is the value for this. These are very very important questions. The same could be asked for different aluminine system. अब देखो 18 aluminine was diatropic मतलब कि aromatic. ये हो गई इसकी property. What about paratropic molecule guys? Yes, what about paratropic molecules? So all cis 18 aniline system is aromatic or non-aromatic. All cis. So all cis के अंदर ना Ganesh, you will not be able to do conjugation. I think that will be more strained. All cis कैसे possible? It's going to be a big molecule, isn't it? Here these bonds are trans. If you are trying to draw all of the bonds as cis, it is going to be like really strained, isn't it? ये देखो सारे cis है. It is going to be a big molecule. And the problem with that is it will become non-planar. Okay, that big molecule, all cis bonds, it will tend to become non-planar. Okay, and that is why the aromaticity could decrease, the resonance energy could decrease. Okay, so yes, all cis is going to be more non-planar as compared to this one, this 18 aniline system. Okay. Now, yes, moving onwards to the paratropic molecule. ये देखो. What are paratropic molecules, guys? जो भी एंटी एरोमेटिक कंपाउंड्स होते हैं, एंटी एरोमेटिक कंपाउंड्स होते हैं, दोज आर पैराट्रॉपिक इन नेचर, ठीक है। सो लेट्स से आई एम टॉकिंग अबाउट 12 एन्युलीन सिस्टम. Let's say I am talking about so 1 2 3 4. अच्छा, एक कार्बन कम कर दिया मैंने. 1 2 3 4 and 5 and 6. ठीक है. So this is your 12 aniline system. Yes, this is 12 aniline system, guys. How many inner protons? Yes. How many inner protons over here? 1 2 3. Definitely, guys, when you are having inner protons, the molecules will tend to have some repulsion between these hydrogens. Or अगर molecule anti-aromatic है, then it will try to become non-planar. Why? Because if it becomes non-planar, at least the molecule will be not having conjugation and at least it will be non-aromatic. तो ये आपको पता ही है, anti-aromatic is maximum in energy as compared to non-aromatic, and aromatic molecule is the minimum in energy according to energy. ठीक है. So if any molecule can go from anti-aromatic to non-aromatic, it will be stabilized. So these kind of molecules, for example 12 aniline system, okay, which have the 4 into n pi electrons, ये हो जाते हैं anti aromatic. Okay. And what happens is, why are they paratropic? Because at low temperature, देखो guys, on higher temperature this is going to become non planar. Higher temperature पे non planar हो जाएगा. And you can say also puckered shape. So we cannot find out the proton NMR on a high temperature. It is not going to give us the original value. So we take this on a really low temperature, minus 180 degrees centigrade, something like that. Okay, the exact values you will get in Jerry March. Okay, so when you take low temperature पे ये जो protons है ये क्या करते हैं? They are going to, even if that causes repulsion, the molecule becomes planar. Molecule has lost the energy, it becomes planar, and then you find out the proton NMR. You will see कि जो inner protons है, 3 inner protons, those are going to be more deshielded to the how many? 9 outer protons. The 9 outer protons are going to be more shielded. ठीक है? More shielded than inner ones. More shielded than inner protons. ठीक है. So when this is the scenario that outer protons are more shielded than the inner ones, उस molecule को हम बोलते हैं paratropic. Okay, and it is found out that all the anti-aromatic compounds are paratropic in nature, right? And yes, guys, do we see this in other molecules? We see this in 16 aniline system also. ये तो 12 है, where n is equals to 3, 4 into 3 is 12. 4 into 4 karo, you are going to get 16 aniline system. So in the 16 aniline system also we see same thing. Inner protons जो है, they will be more deshielded than the outer protons. ठीक है? Yes. So this is very very important. Why does this deshielding and shielding effect happen? ये तो आपको पता ही होगा guys. I just suppose that you all know this. Why does the shielding and the deshielding effect happen? Yes, diamagnetic anisotropy, isn't it? Diamagnetic anisotropy. What is that diamagnetic anisotropy? That is, if you are placing benzene in the external magnetic field B0, okay, what happens is, benzene क्या करता है guys? It reverses the डायरेक्शन या फिर ऑपोजिट द अप्लाइड मैग्नेटिक फील्ड इन द सेंट्रल पोर्शन में तो अपोज करेगा अप्लाइड मैग्नेटिक फील्ड को, एंड आउटर पोर्शन में क्या करेगा, रीइंफोर्सेस मतलब कि एड्स, कंबाइंड टू द एक्सटर्नल मैग्नेटिक फील्ड. So as a result, if any group is present inside or let's say above the pi electron cloud, तो वो तो हो जाएंगे shielded, or if any group is present outside, that is going to be more shielded. इसको हम बोलते हैं diamagnetic anisotropy effect. Yes, you want to see more examples on diamagnetic anisotropy effect? Wait for 1 second. Diamagnetic anisotropic effect. So, how do we see an example? हमें कैसे पता? बेंजीन के अंदर तो हाइड्रोजन्स है नहीं. You have seen such example on aniline. Now let's see a variation of the aniline. हाँ, let's see a variation on the aniline. Let's say ये 10 aniline system था. For example, it is having 10 pi electrons. But 10 pi electron system was too strained and then it became non-planar. तो हमने क्या किया? We just put a methylene group over here to hold the molecule together to make it planar. ठीक है, अब मैंने यहाँ पे लगा दिया methylene. Now what do I see, guys? These methylene hydrogens are very highly shielded. Okay, these CH2 protons are very very highly shielded. Highly shielded का मतलब क्या है? -0.7 ppm something. It could be greater than that also. -1.4 भी हो सकता है. ठीक है, but it is very highly shielded. This is just a rough example, not the exact value. Okay, just एक rough example है. Exact value आपको book में मिल जाएगी. Okay, so as compared to all the other hydrogens जो बाहर की तरफ जा रहे हैं, yes, so these hydrogens are very highly deshielded, approximately 8 to 9 ppm value, उससे भी ज़्यादा हो सकता है. और ये जो inner proton है, those are going to be even more shielded, मतलब having a negative ppm value. That is the whole important point. Okay, having a negative value. Okay, so this is what we are talking about, guys, today. बहुत ज़्यादा important है ये concept of aromaticity, right? And there are plenty of questions asked in the exam on the concept of aromaticity only. Now, what are we going to do next? We have more sessions planned up. Okay, अभी just इसके बाद कल, that is tomorrow, we have one more session planned up for aromaticity. In that, we are going to be looking at the previous year question practice. Okay, practice and more concepts of aromaticity we are going to do. That is what we are going to do tomorrow, same time, 9:15 a.m. All right, and yes, guys, a new course is coming up very very soon. जैसे ये वाला कोर्स है जो मैंने आपको दिखाया, this one, Chemithon practice batch. So just like this, I will be launching a new course very very soon, only for question practice, only for new question practice, right, on Unacademy Plus. This is going to start really really soon in the month of September. All right, और ये जो बोलते हैं ना लास्ट मिनट वाली जो एकदम धांसू वाली प्रैक्टिस है वो करेंगे हम यहाँ पे. ठीक है, and nothing else. This is going to be like really really important. So if you all want to join Unacademy Plus, do so without any delay. We are going to do really really important questions in Unacademy Plus, and miscellaneous questions we are going to do. All right, और मैं आपको कल मिलती हूँ at the same time. I'll see you all tomorrow. Okay, on the same time. Yes, so bye bye everyone, and we'll see you very very soon. Bye guys, take care all of you. Have a nice day.